Thank you for being here with us and welcome to today's webinar. It's actually the last 5G MOBIX webinar, and today our presenters will give us a valuable insight into the project's evaluation and recommendations. My name is Eva Christoforou. I am a community officer with ICCS, the Institute of Communication in Athens, and I'm also the dissemination task leader for 5G MOBIX. I will be the moderator for today's started. I would like to inform you that throughout the event, opportunity to submit your questions to the question box that you can see on your control panel on your screen. We will collect all these and we'll address them at one time towards the Q&A session end. And in case you're experiencing any technical issues with the audio, or perhaps you're not viewing the presentations properly, the chat box that you can find again on your control panel to answers. I'd like to move on to the introductions. So I would like all the speakers to turn on their webcams. Great, thank you, and a warm welcome to you all. So together with us today, we have Dr. Konstantinos Katsaros, or Dinos. He is the head of Intelligent Networks and Services Department at the ISENS Group of ICCS, which is at the National and Technical University of Athens. And he's also the evaluation leader in 5G MOBIX. We also have with us today Marta Miranda. She's a project engineer at CITAG in Spain. And then Maya Federley, she's a senior scientist at VTT in Finland. And last but not least, we have Manuel Souza. He's the head of Department for Perception, Interaction and Usability at CCD in Portugal. Well, thank you all for being here, and I'm looking forward to seeing your presentations. And I would not like to take any more of your time. So Dinos, the floor is now all yours.
Thank you, Sevi. Thank you very much. Just let me share my screen and go to presentation mode. You can see my screen, right?
Yes, we can see your screen.
Okay. Thanks everyone for joining this last webinar of 5G MOBIX. This is going to be a short introduction about the project. So as most of you, if not all know, 5G MOBIX is one of the ICT 18 projects, European projects focused on trials, on conducting trials regarding cross-border corridors, cross-border corridor mobility, with the purpose of assessing 5G capabilities for CAM services. We had a tough job to complete, given the size of this project, 59 partners, lots of test beds. You can see here all partners that contribute to the results that you are going to be informed about. Regarding the scale of the project, and I must note the presentations that our colleagues are going to make are a consolidated and high-level view of the results, because as you can see, we had 2 cross-border corridors, 4 complementary European trial sites, 2 Asian trial sites, 29 5G GNOBs. We work both on NSA, mostly on NSA architecture, but we did investigate issues regarding standalone deployments, 21 automated vehicles, and lots of use cases categorized in 5 clusters following 3GPP standards. The trial sites, as you may already know, the Spanish-Portuguese one, the Greek-Turkish one, the 4 European trial sites in Finland, France, Germany, Netherlands, and our Asian friends in China and South Korea. So just to give you a very short, brief overview of what this is going to be about, we had a multifaceted evaluation approach, and we're going to expose that first, focusing on the technical evaluation, where we focus on technical aspects regarding 5G deployment, network layer issues, radio issues, issues related to the application layer. But we also had extensive work conducted in the context of impact assessment, where we investigated business and societal aspects. And of course, last but not least, we had an very interesting survey assessment of user acceptance on how users perceive these services, these applications in cross-border corridor environments, especially in the presence of mobility. And we welcome questions for this work. We are going to have a Q&A session at the end of the presentations. Feel free to use the chat box as mentioned already by Sevi. I would like to thank you and pass the floor to Marta with the technical evaluation results. That's it on my side.
Thank you, Dinos.
Okay. Hello, everyone. Good morning, everyone. As commented, I'm going to talk about the technical evaluation in 5G MOBIX, and in this webinar, I would like to give a very brief overview of the methodology that we follow in this project in 5G MOBIX, just to give the framework for the results. And then the idea is to compare with all of you the main results, the main conclusions that we obtain for the technical evaluation in 5G MOBIX. So about the methodology, this B model, this B process defines or summarizes the methodology followed in 5G MOBIX. The starting point are the cross-border issues, because the objective of the project is to evaluate the 5G behavior in cross-border environments. From these cross-border issues, the cross-border corridors trial size defined a set of test cases in order to validate the cross-border issues, in order to evaluate the cross-border issues. And as we are talking about the technical evaluation, the focus of the evaluation are the data flows involved in these test cases. Mainly, we are talking about SIG messages, we are talking about video or sensors information or whatever. For these data flows, we have defined a set of indicators, mainly related to the connectivity, talking about reliability, latency, throughput, and so on, but others related with the handover process, with the events involved in the handover process. So this is the preparation of the evaluation methodology, and then we have to go to the trials in order to collect the data for the evaluation. So on the right side of the V, you can see that in the framework of the project, we had a centralized test server where we store all the data in the common data format, and in addition, we have a central database in order to make the data more accessible and more agile. From this data, we obtain the KPI results that allow us performing the complete connectivity analysis. From this connectivity analysis, we could evaluate the impact on the connected and automated mobility. This is very related with the performance of the test cases. And in addition, a mobility impact that is directly linked to the cross-border issues. So, well, as you can see, the center of the evaluation is the cross-border issues, and the cross-border issues. So, let me define what is exactly a cross-border issues and what is a considered solution. Well, the cross-border issues are the set of technical challenges towards seamless cross-border CAN functionality over 5G. In the framework of 5G MOBIX, we have defined 11 cross-border issues. And for these cross-border issues, we have to define a set of the most promising technical approaches to address the identified cross-border issues. In particular, we have 26 considered solutions in 5G MOBIX. As you can see, can be alternative solutions to the same cross-border issue, meaning that for the cross-border issue, for example, number 1, we can have 1 considered solution, 2, 3, or even more. And this is very interesting. The cross-border issues or the same pair cross-border issue considered solution can be analyzed by different cross-border corridors trial sites, meaning that we can perform cross-check evaluations. So in this slide, you have the list of cross-border issues with the associated considered solutions. Well, as you can see, we were evaluating the roaming interruption, both in non-standalone and standalone, the inter-element interconnection latency, the session and service continuity, data routing, meaning the home routed and local breakout roaming configurations, millimeter wave applicability, network slicing applicability. So in the following slides, I'm going to provide the results for the main cross-border issues with the most significant results. So let's start with the mobility interruption time in non-standalone networks. So in this case, both cross-border corridors trial sites, Spain, Portugal, and Greece, Turkey, selected the same considered solution, that is the release and redirect with STM interface using a non-standalone network. In the figure, you can see the handover times, both in LTE and radio. As you can see, the results are comparable in both cross-border corridors. At the LTE layer, we have 37 milliseconds in Spain, Portugal, and 56 in Greece, Turkey. And at the new radio layer, 230 milliseconds in Spain, Portugal, and 195 milliseconds in Greece, Turkey. You can see also on the right side the time to restore the IP session that applies to the local breakout configuration. In this case, you can see that the result obtained in Spain, Portugal is about 4 seconds. All these values are average values. What this value is higher than the one obtained for the handover, for the handover time between the source in OB and the target in OB. So conclusions here. First of all, that the handover was achieved between the non-standalone networks, both in home routed and local breakout. We have also talked about the reproducibility. As commented, the results are comparable in both cross-border corridors in the project. The interruption times, meaning the time difference between the source in OB and the target in OB, in home routed are compatible with most CAN functions. But on the other hand, the way to restore the IP network connection in local breakout increased the interruption time to 2 seconds, meaning that most autonomous driving functions cannot be executed under this roaming configuration. That is why, because there is not a standardized process to trigger the change of the data session in local breakout. In fact, it had to be done from the UE side instead of the network side. Okay, second, let's talk about the mobility interruption time, but in this case in standalone networks. The considered solution here is the release and redirect using a standalone network. These results were provided by the Dutch trial site. In this case, they are providing the roaming interruption time as the time duration between the network in which the network connection to both the home and the visiting networks is lost. You can see that in this case we have on average 15 seconds. But well, as conclusions is that the handover was achieved between the standalone networks in local breakout. They obtained 100% roaming handover success rate. But again, the technology seems not to be ready for the dynamic release. In fact, they have to perform the test by pre-configuring the SIM cards because the technology is behind the implementation of these CAN services. And well, again, the interruption time is below the requirements of CAN applications. Okay, let's move to the inter-PLMN interconnection latency. In this case, the objective is to compare the internet-based interconnection against the direct interconnection. you can see in the slide the results obtained in Greece, Turkey for the same user story, in this case the CYTIC. They perform the same test with public internet and with direct interconnection, and the end-to-end latency with public internet is 112 milliseconds on the medium, but with direct interconnection, this end-to-end latency decreased to 45 milliseconds. So the conclusion here is very straightforward in the sense that the direct interconnection reduces significantly the end-to-end latency compared to the public internet interconnection. Okay, session and service continuity. In this case, I am highlighting here the multi-modem and multi-SIM connectivity considered solution. This is not the only considered solution that we deal with for the session and service continuity, but we have a set of trial sites that compare the passive mode in multi-modem and multi-SIM connectivity. The passive mode is the best or high priority connection against the link aggregation when you are able to maintain multiple connections in the same data session. Okay, results provided by the French trial site. In this case, they were comparing the link aggregation with the single SIM and the passive mode on board units. So in this case, the end-to-end latency, they obtain an end-to-end latency of 25 milliseconds with passive mode, but 20 milliseconds with link aggregation, and 0.4% of packet loss with passive mode, and not packet loss with link aggregation. Similar results in Finland, highest performance in link aggregators compared to, again, single SIM and passive mode. Again, the same trend here, less packet loss with link aggregation, and again, the end-to-end latency in link aggregation is 78 milliseconds compared to the 76 milliseconds with single SIM. In this case, you have to focus on the trend of the results and not in the numbers itself, because, well, as you know, we are comparing different network architectures, different use cases, meaning different data flows. So the idea here is to get an overview of the trend and not the number itself. Germany, service interruption time with passive mode. With ping test, they obtain 300 milliseconds, but in tests against an NQTT, in real tests in the framework of the use cases, the service interruption is from 1 to 3 seconds. So in this case, this talks about the NQTT establishment of the connection, the NQTT configuration, and so on. That is why the service interruption is increasing in this case. And finally, China, the same trend, end-to-end latency of 34 milliseconds in link aggregation, and 10% of packet loss with passive mode, but no packet loss with link aggregation. So as a conclusion, as you can see, the latency and reliability benefits from link aggregation compared to the passive mode. Data routing. So in this case, we are comparing the home routed in non-standalone with the local breakout in non-standalone. Well, as you know, the difference here is in the visited network, because the UE is served by the home PLMN in home routed, but is served by the visited PLMN in the local breakout. So the difference is the path between the two cores that you can see in the figure on the right, this path between the two cores. So that is why we are obtaining in Spain, Portugal, 60 milliseconds for home routed and 40 milliseconds for local breakout. So again, the results are positive in the sense that, well, local breakout provides shorter latencies when driving in the visited network compared to home routed. But the positive thing is that both home routed and local breakout latencies are compatible with most CAN functions. Okay, and finally, I'm going to provide the results for the for these features, for the slicing in a standalone. In this case, was the Dutch trial site, the one providing this very, very interesting result. The slicing is the partitioning of data and services in different slices to guarantee the service performance. So in this case, they compare three test cases. The first one is the baseline test case. In this case, they are only testing the CAN traffic. This case is a remote driving use case where the CAN traffic is video. So the test was only obtaining the user plane latency and also the user experience data rate for the CAN traffic. In the second test, they added background traffic from internet, from an IP server, and in this way they mix the CAN traffic and the background traffic in the same slice. And finally, and this is the new feature to be tested here, that is about the slicing, they separate the CAN traffic in a high priority CAN slice to the background traffic in a low priority internet slice. So on the right, you can see in the figures that both the user plane latency and the user experience data rate are similar in the baseline case and in the slicing case, first and third test cases. But when they are mixing the CAN traffic and the background traffic in the same low priority slice, the results are quite worse. So conclusions, well, the network slicing can fulfill the quality of service requirements. Well, just to be aware that the CAN slice should not be polluted with background traffic because the scheduler at the GNOV cannot differentiate high and low priority data. Okay, complementary to all this analysis performed at the local sites, we have also the opportunity to move the trial site implementations to the cross-border corridors. And this was very interesting from the interoperability point of view, and also to move and to test the implementations developed in the trial sites to the cross-border corridors. So this is the case, for example, of the H dynamic map in the case of the German trial site in Spain, Portugal, or also the H discovery service protocol from Finland that was already tested in Spain, Portugal, the multi-SIM onboard units from France that were already tested in Spain, Portugal, the H computing for cooperative services, the messages that will allow us comparing the results from the Dutch trial site and the Spanish-Portuguese trial site, the cross-border corridor. And well, finally, the Finland contribution in Greece, Turkey, with the live streaming vehicle system, the Levy system. And of course, we have also to talk about the lessons learned during this technical evaluation. First one is about the 5G devices. They are still unstable and sometimes subject to the regional settings. This means that so far they are not plug and play, let's say, devices. We have also to talk about the 5G behavior that is affected by interference of objects and also by the weather conditions. When I say interference of objects, I'm talking about buildings, metallic road signaling, mountains, bridge, foliage, or whatever is affecting the latency and the stability of the network. And well, finally, and this is about the location of the trials, because well, we have to match the location of the trials with the point when we would like to perform the handover in order to be able to evaluate both at the same time. And sometimes well, it causes some instability in the network because of the proximity of the handovers and overlapping of handovers and so on. So I think that the conclusions of all of this is that the 5G delivers a capable solution. that you can use now, but can further evolve. What is the meaning of all of this? Well, 5G delivers a capable solution. Well, as you can see in this presentation, there are almost seamless cross-border mobility. The CAM performance with 5G is significantly better, meaning that better results for the latency, for the throughput, and so on. And the solutions are scalable, allowing for more users and more services. That can use now, yes, a large set of CAN services can be supported today. The services with higher needs can be adapted to the network status, and also there can be a collaboration between telecom networks and service providers in order to tailor the needs to new service. And can further evolve, of course, with money, with the understanding of the power of the current 5G capabilities, and also with the synergies between among all the stakeholders on this. Well, thank you very much for your attention. That's all from my side, and well, I will be very happy to answer your questions at the end of the session.
Thank you so much, Marta. And now let's turn to Maya with a presentation on the impact assessment.
Yes, hi everyone, and I will now aim to find the right screen to present.
I think we can see the right screen. Yes, and if you put it on presentation mode.
Yes.
Super.
It seems to take a while.
Yes.
Okay, great. So good morning, everyone. I'm Maija Ferelei from VTT, Technical Research Center of Finland, and I will briefly present some key findings from the impact assessment activity. Sorry, what we have carried out. I have led this impact assessment activity, and so I will talk about those, but let's say that it's a lot of things and little time, so let's take a quick view on those. So the main objective of the impact assessment was to evaluate the impacts of seamless service provisioning across borders from a socio-economic perspective, and in terms of to assess the potential impacts on quality of life, in terms of personal mobility, traffic efficiency, traffic safety, and the environment. And then also to assess the estimated cost and benefits of the solution to verify analytically if the investments on the 5G corridors provide good value for the money for the society. So these assessments have been conducted from a societal perspective and not focusing on for example, a business case of an individual organization and cost benefits of those. And before going into to these two topics, quality of life and cost benefit analysis, I would still like to make a remark that the approaches of these assessments differ in the scope. So quality of life impact assessment focused specifically on the 5G MOBIX use cases, and whereas the cost benefit analysis has a wider perspective on costs and benefits of 5G cross-border corridors and connected automated drive mobility without focusing on specific use cases. And another note is that the 5G MOBIX trials were mostly carried out in closed rows and of course limited scale of the trials due to that, and also due to the many kind of issues that need to be solved in a very specific setting. And the number of vehicles used in the trials range between 1 and 4. So a major part of these solution services discussed in this study cannot yet be deployed in realistic conditions, even in a limited context, as you very well understand. So And also the business models and the actual future services, kind of complete services, have not yet been specified in detail. And even more so when looking at the specific cross-border context. So these factors affected the impact assessment work, so that we in both in choice of methodologies that we could use, and also and specifically availability of data for the assessment. And so in this future-oriented activity of impact assessment on societal level, we were faced with especially with the lack of credible quantitative data of almost all types of data that we would need for a quantitative assessment. So looking first about on the quality of life impact assessment methodology, it builds on the impact assessment. The adaptive methodology was the framework for automated driving developed by the trilateral working group on automation in road transport, and the similar approach has been applied in Autopilot project earlier that focused on automated driving and enabled by Internet of Things. And this framework provides a comprehensive picture of both potential impact mechanisms and their pathways, and it ensures a systematic assessment and also reasoning how these impacts could be realized. The baseline in the assessment was the connected automated driving with connectivity issues in terms of session and service continuity. So in comparison to the seamless connectivity. So that was what was used for comparison. And like I said, the focus was on identification of the most important impact mechanisms where 5G is expected to have an effect. And this was done for each evaluation area and each use case. And the use case descriptions that were used in this quality of life impact assessment were developed based on the user acceptance activity that will be presented soon. And these were used because the descriptions allowed to illustrate the services from an end user point of view. And these user acceptance use case descriptions were summarized for quality of life impact assessment to describe the main functionalities of the service. And the use scenarios assessed here in this study were lane merge and overtaking, HD maps, automated shuttle, remote driving across borders, platooning with see what I see functionality in a cross-border setting, and truck routing. One use scenario, extended sensors for assisted border crossing, was excluded from the assessment. It was concluded that it would be impossible to implement without seamless cross-border connectivity, and so, thus there is no baseline to compare in the assessment. And the approach was, the work was carried out as an expert assessment. And here just a quick one example of how it looks like, the framework and the work carried out. And I'll just take one single line here, so illustrative brief example, that the speed behavior describes the speed choice here. I don't know if you see my mouse, but basically one green box here. It describes the speed choice of the automated vehicle and potential changes in different situations. And with 5G, it is assumed that the vehicle receives information on the upcoming end of a lane and slower car, and the vehicle can automatically adapt speed and perform lane change. In the baseline situation with the connectivity issues, the vehicle receives delayed information and needs to slow down or follow the car in front instead of overtaking. So this improved interaction with other vehicles and enhanced visibility and anticipation of intentions are likely to improve safety, the blue arrow here, And then while the lack of slowing down is beneficial for traffic efficiency as well, the red arrow here. And then smoother speeds and less brakings are likely also to cause less emissions, which has an effect on the environment. So speed behavior is assumed to have an impact on safety, efficiency, and environment through these mechanisms described here. And a similar analysis was conducted for all impact mechanisms and use scenarios. So jumping to the results, overall results, and summarizing those, it was concluded that in a quality of life impact assessment that the most important impact mechanisms related to the 5G enabled connected automated mobility in cross-border context is speed behavior, interaction with other vehicles and vulnerable road users, frequency of harsh brakings, and traveling reliability. Small improvements for traffic safety and efficiency were seemed possible based on this assessment, and the user scenario with most impacts on quality of life is likely to be the lane merge and automated overtaking. And impacts on societal level, looking at the whole kind of traffic system, are likely to be negligible due to the specific nature that these cross-border user scenarios. But of course, on the local level, travelers and sites and even some areas may experience larger benefits due to the improved border crossing. So let's see in a cost-benefit analysis, the methodology was to, or let's start from the beginning. On a general level, cost-benefit analysis is a process of comparing the estimated costs and benefits of a project, program, or policy to verify if it provides a good value for money for the society. So do the benefits outweigh the costs? Due to the data availability constraints that we had in this project, or in this topic in general, the approach followed was finally a break-even analysis that identifies the point at which the attributable benefits resulting from the deployment equal the costs. So specifically looking at how high do the wider benefits have to be in order to justify the forecasted infrastructure costs. That was the assessment was carried out for 4 infrastructure investment scenarios and this both the data on the investment costs and then also the approach was adapted from a 5G MOBIX deployment study. So there were different investment scenarios, and then there were 5 European cross-border corridors were covered: Spain, Portugal, Greece, Turkey, Germany, Netherlands, Finland, Norway, and Spain, France. And the costs and benefits for 5G border crossing were assessed without specified use cases, and the coverage of the stretch of a highway was also adapted from the deployment study, similar to deployment study. So it was 40 kilometers along the cross-border corridors. So there's a difference between these approaches in quality of life and this cost-benefit analysis. So the external costs of transport considered here were fatalities, serious accidents, slight accidents, and carbon dioxide emissions, delays, and well to tank. And a reduction in these represent these wider societal benefits. This is really briefly an illustrative example of one scenario R, where investment in 700 megahertz 5G band is assumed in 2023. And the case is Spain-Portugal corridor, where the external costs have been assessed for each of the categories, and then reduction in these externalities have been calculated to cover the costs that are calculated for the investment. And then again, going to the actual results, the reduction in the external for all of these assessments is to offset the investment cost was achievable for Spain, Portugal, Germany, and the Netherlands, and Spain, France cross-border corridors. Based on the literature, it seemed that these could be reached because the level of decrease in externalities was ranged between 0.44% and 1.99%, and this seems possible. Due to the low traffic volumes at the Finland-Norway corridor in Lapland, and also because of the high investment costs in that area, the break-even is very unlikely to be achieved based on this analysis. And then the investments at the Greece-Turkey corridor is a more challenging case, that it is not likely to be offset by the benefits included in this analysis. But on the other hand, there could be benefits to trade and logistics that could really well, that are not covered in this, but could really well offset the cost. So that is kind of one note to that case. And as overall conclusions of both of these impact assessment areas, quality of life impact assessment and the break-even analysis, the 5G is expected to affect automated driving in cross-border context through the following impact mechanisms: speed behavior, interaction with other vehicles and vulnerable users, and frequency of harsh brakings and traveling reliability. And the user scenario with most effect is likely to be lane merge and automated overtaking. And then from the perspective of the break-even analysis, it shows that all corridors except the Finland-Norway corridor, that there is a good indication that the deployment can across the could allow offsetting the infrastructure costs considered in this in the deployment study. And these then again, like I said in earlier, there were quite a lot of challenges in getting the quantitative data, and then we had to do numerous assumptions and estimations even in this qualitative approach. So these results should be seen as indicative, but still kind of informing about the potential of impacts and then the level of impacts that could be expected, and in relation to the costs and the investments needed. So that was all from my part, and I'm also happy to answer any questions if you would like to ask. And of course, I would like to especially acknowledge the actual the teams that are behind this work. So thank you for my part.
Thank you, Maya. And now we come to our last speaker, Emmanuel.
So, thank you. So my name is Emmanuel Souza, and I have coordinated the user acceptance evaluation task of the 5G MOBIX project. Now this activity had essentially two major goals. So the first one was to evaluate the acceptability of the 5G-enabled automated driving user stories or use cases. And the second one is actually probably the most important in the context of this project, that is to evaluate how breaks in the service continuity in the particular context of the border crossing. So when there is the handover processes on the border, and how those processes interfere with the user experience, and what will be the consequence on the acceptability. And we wanted, and we tried, and we did do this with actual users. So our approach, so we had one major challenge, that is how to separate the user experience of the CAM user stories from the service continuity breaks. So what is the generally acceptability of the proposal of the user story as it is, and how was that affected particularly by the service continuity break, and separate the two effects. And our approach was basically to try to have this kind of comparison, to have first the users trying the user story in what we call the local context, where there was no handover processes. So it was on a fixed basis, so no crossing between the borders, and then to compare that with the actual cross-border context where there was this context. So that ideally would allow us to compare, to understand what is the effect, the acceptability of the user story, and what is the consequence of the border. And this was mostly what our main goal when doing these evaluations. So then we use a set of KPIs to evaluate the acceptance. So the main one was the actual intention to use, but then also these like perceived usefulness, perceived ease of use, trust, and reliability, which are known from the user acceptance literature to be strong predictors of acceptance. So this was transformed on a survey, a questionnaire. So each of these constructs was translated into a set of questions, and the users would reply to these questions with an answer from I disagree to I strongly agree. Then we calculated an average to determine the value of the KPIs. Beyond this questionnaire, we also had interviews and focus groups to have more qualitative data from the users and try to understand exactly what were the points of the interaction that may or may not have disrupted user experience and the acceptability. Now we focus on the ESPT user stories for logistics restrictions mostly, and because they also cover a large broad of the kind of user stories that the whole project analyzed. And they were mostly the HD media service. So this was a video streaming service that was available to the passengers of a bus traveling from Vigo to Porto. They had a screen in front of them, and they could stream movies and signals on the device while crossing the border. Then we had the advanced maneuvers that were tried out in the project. So maneuvers that were tried out on the border, like lane merge, overtaking, and HD maps, that was having a car driving with the help of high definition maps that was built from surrounding cars and from the infrastructure information. And finally, what we call the shuttle user stories that involve the remote driving. So the shuttle was remotely driven on occasion due to some obstacle, for instance, and also the cooperative automated system. So this means that the shuttle was receiving information from, in this case, from the infrastructure, from a pedestrian's radar that was installed near the bridge, and that was sending information to the shuttle and made the shuttle stop on approaching of a pedestrian. So we wanted to have these user stories evaluated. So as I said, that our general methodology was the comparison. That was not always possible on a real setting, so we had to make different methodologies depending on the user story and on the conditions of each one. So we did real world trials for the HD media service. So we had actual passengers of the bus, users of the service, experimenting the service and doing their evaluation. So real world evaluation. We had controlled trials, and this was done to some of the advanced maneuvers, partially done to the advanced maneuvers, and also for the shuttle user stories. So in this case, we had then the comparison between local and cross-border. So the local trials were done at CTAG premises on their test track, and the cross-borders were done on the actual border on the bridge. We had online interviews. So why do we have them? Because the advanced maneuvers, we were not able to fully complete them on the actual tests premises near the new bridge between Portugal and Spain. So we had to come up with a way of how can we do this with users using, for instance, an online interview. This was kind of a challenge. So we developed simulations based on a driving simulator to provide a viewer, tried to provide the user the experience, the first person view of a driver while crossing the border using these surfaces and observing the advanced maneuvers, the lane change, the overtaking and the driving with HT maps. Because we wanted to analyze the local and cross-border context, we came up with comparisons. We compared the best case scenario where there would be no network disruption with average scenario with some network disruption was to be expected and worst scenario where large network disruption was to be expected. So loosely, the best case scenario of network conditions would correspond to the local trials, and the average and worst network connect conditions would correspond to the cross-border crossing. And then we had a larger scale survey online where several of these user stories, the advanced maneuvers and the shuttle user stories, were also tried out. So the respondents were presented with descriptions of the user stories, with some graphical descriptions, some small video clips of this kind from an outside view. And they again answered this best, average, and worst case scenarios. So each user only answered one of these scenarios per user story. So we had about 257 answers, complete answers to this. So I will not go intensely on the results. So what we had in the end was several user stories compared to several different methods. We collected the KPIs and tried to make comparisons between them and see what kind of information we could extract, what we can learn from them. So what I will present is a brief summary. So starting for the HT media service, it was actually quite positively evaluated, even despite some service degradation. Important to mention that the major reason for the service degradation was actually not the connection itself, but the fact that inside the bus there was a MIFI router that was conveying signal to the several tablets, and it was a bit of a stretch. So the users experience a bit of lag on the video, but still they quite have some positive evaluations, and it seems in this case that the simple availability of the service by itself is actually quite regarded positively. So is regarded quite positively, sorry. So users actually enjoy having this kind of services available while on a trip. As for the shuttle user stories, again, they were also positively evaluated in terms of acceptability. So from a scale from 1 to 5, they were mostly above 4. And this was across the methodologies. So this was true both for the real the controlled trials on the bridge with users trying out the service, and from the survey. We found no big differences between the local and the cross-border trials in terms of evaluation. This was on the cross-border setting. What we observed is that the handover performance, technically speaking, was quite high. So there weren't no large difference between what the users could observe on the bridge or on the test track. When we interviewed most of these participants, and this is one important lesson to take, I think, is most of their concerns are related with safety. So they enjoy the service and they seem to be willing to use it. Their concerns with safety. So one important lesson to take here, we need to ensure that the service is and seems to be safe for them to use them. In terms of the KPIs, what we notice is, and on coherently with this evaluation from the users is that the trust and the perceived usefulness, they have strong correlations with the actual intention to use, which is in agreement with most of the literature on user acceptance, and that's what we actually observe from the data we collected. As for the advanced maneuvers, so likewise, the users, this is an important point. So the user recognized the value of the 5G enabled CAM user stories. So they actually enjoy the idea of being in a car that has access to information coming from other cars, coming from the infrastructure, and that makes the car behave in a way that they see as safer, mostly this. We have positive evaluations above 4 again. Now, the graded network conditions do affect acceptability, but we notice mostly on the online interview, and this is a curious fact, that average network conditions actually had lower acceptance scores than the worst network conditions. And this was probably due to the fact that as the user stories were described, one thing I forgot to mention, these scenarios and the consequence of the network in the vehicle behavior, we developed them based on inputs and on conversations with the technical experts that implemented and that created this user stories. But as it was, the average case scenario of network conditions actually sometimes resulted in the vehicle behaving a bit, I wouldn't say more, maybe I would say a bit more erratically, in the sense that because he was receiving information that could be delayed, he sometimes would try out a maneuver and then cancel it. And that sort of behavior was evaluated as less positive than the behavior of simply being conservative in the behavior and just, for instance, following without trying to overtake until the vehicle was able to do the maneuver by its own sensors. What we observed, so in this average case scenario, is that the trust KPI was the most negatively affected. And because, again, the intention to use was strongly correlated with perceived usefulness, and trust, because trust is affected, intention to use was affected. So some conclusions and lessons learned. Acceptability was in general positive. The user stories were well evaluated, even in situations with degraded connectivity. They were considered useful, easy to use, and trustable. And participants actually valued the 5G enabled CAM features, so the idea of having information from the infrastructure, from the surrounding cars. Network performance affects acceptability and particularly trust, but the relation is not straightforward because it will depend on the resulting vehicle behavior. So behavior that is somewhat seen as more unpredictable was considered less trustable. This actually points the focus on the need to have fail-safe mechanisms that should be implemented to ensure safety, but also to maximize the feeling of safety. So how building systems that actually make users feel safe, even if the technical and technological solutions are not the ideal ones. And that's it. So thank you very much.
Thank you so much, Emmanuel. All right. Thank you all for your presentations and your inputs. I would like to ask the speakers to turn on their webcams again so we can move on to the Q&A session. Keeping an eye on the time, I know there are just a few minutes left. However, I think it's a nice opportunity to take some questions, and there are already some questions that came in during your presentations. Emmanuel, starting with you, a question: how would you compare the different data collection methods that were used during the project, during your work, and which ones do you think provided the best results?
I think from what we observed was that the actual trials where it was possible to compare users on the local trials, the cross-border trials, and the interviews, the online interviews were actually the ones that produced the better, more relevant results. So the ones on the border, because, well, they were the ones that users would actually able to compare one situation with the other. So the most approximate impression of what would be to actually be inside this kind of vehicle. The interviews, on the other hand, would add one interesting value, because they allowed for the experimenters to actually control very well what the users were observing and to ensure that they understood fully what was happening. And because of that, I think they also produced the most fine-tuned results. So yeah, online interviews and the actual trials on the border compared with the local trials are the most valuable ones, I think.
Thank you, Emmanuel. A question for Marta. Which MNOs and radio vendors provided the GNB in the 2 cross-border corridor trials? This question comes from David.
So in Spain, Portugal, the MNOs are Telefónica on the Spanish side and NOS on the Portuguese side, and in charge of their infrastructure was Nokia, both Nokia Spain and Nokia Portugal. And in the Greece-Turkey corridor, Cosmote MNO from the Greek side, Turkcell from the Turkey side, and in charge of the infrastructure, Ericsson.
Thank you, Marta. There's a question coming in from Vasiliki. Better results of latency were observed in LTE versus NR. Do we have any explanations for that?
I assume that. Yeah.
Sorry, continue.
Sorry, I assume that we are talking about the results I saw for the handover time in home routed. Sorry, in home routed and in non-standalone network. So, to be honest, no answer for that. No.
Right.
I think that the process right now, as you know, the non-standalone network is not a pure 5G network, in the sense that we need the support of the LTE, and that is why we need a second step in order to attach the 5G secondary cell, and that is why we need more time to perform the handover.
If I may add, Marta, to this, just to explain that the presentation of the results being structured in LTE and new radio do not actually reflect separate trials, like we had LTE alone and then we had new radio alone. It is because, as you mentioned, that we had NSA, non-standalone deployment, that we had the LTE part that would need to perform the handover, plus the new radio part, the new radio leg, as it is termed by the vendors. So it was not a comparison between 4G and 5G and 4G performs better. It is the 4G part of the non-standalone deployment plus the 5G part.
Exactly.
We do not conduct experiments purely with 4G deployment.
Exactly, the same test, but the 2 steps to perform the handover.
All right, thank you both. And I think I can take 2 more questions if if you also agree. This one is for Maya. The results of the quality of life impact assessment and the break-even analysis seemed somewhat contradictory. What do you believe that was the case?
Yeah, there is a kind of like explained in the presentation briefly that they covered a quite different scope, because the quality of life impact assessment focus on the exact user scenarios and the exact cross-border situation, specific situation, and then on the other hand try to see the effect of that on a societal to the whole traffic system, if it's more efficient or if it affects the mode choice of the people, for example. And then on the other hand, the cost benefit analysis focused on looking at the additional need for additional investments for cross-border corridors, and covered, like said, the 40-kilometer stretch or range of the corridor. So there the expected benefits naturally would be larger, covering a bit kind of the longer or more extensive benefits of the 5G enabled CAM solutions, and not just the exact border crossing situation and the limited use cases that were covered in the trials.
Thank you, Maya. And one last question, perhaps. Is there a plan to deploy large scale of commercial network in both cross borders?
Well, I can take this one. This is a very complex discussion. Actually, in the case, perhaps Marta can explain more regarding the Spanish-Portuguese case. I can explain two aspects. The one regarding the Greek-Turkish one, the Greek-Turkish corridor. I must note that this is a hard border. It is where passengers and drivers and cargo needs to stop, get checked paperwork, lots of paperwork, and then cross the border. So it is not as fluent, let's say. The flow is not that easy, which comes also with difficulties in planning for a large scale deployment. In general, the answer also lies, I mean, beyond the particular Greek-Turkish border, also lies on what happens on the CEF2 program, where additional funding would be provided to support larger scale deployment across border corridors. To the best of my knowledge, there is no plan to support the Greek-Turkish corridor, but other corridors in the region. I think this is the case with the Greek-Bulgarian corridor, to the best of my knowledge. I don't know if there is any similar news regarding the Spanish-Portuguese corridor, but the situation is quite different, I would say, there.
No idea about the Spanish-Portuguese situation.
All right, then thank you, Tina and Marta. One last question. I think we could take this one as well. Marta, this one is for you. Regarding the mobility interruption time in the NSA networks, is there any reference time to restore IPS session in LBO from the Greek-Turkish cross-border corridor?
As far as I know, no. They do not have any measurement about the local breakout interruption time.
All right. Thank you. Well, I wish we could take more questions, but I'm afraid we exceeded the end of our planned agenda. Let me move the slide. I would like to thank you all, the speakers and the audience, for being part of this last event. Of course, if you have any additional questions, you can find our email on the 5G MOBIX website, and we are more than happy to send the questions to the presenters. And just before we sign off, I would like to inform you that you can find all the previous webinars from the trial sites and the cross-border corridor trials on our website, on the link that you can see now on my screen. And yes, is there anything I would like for the presenters? Is there anything else you would like to touch upon before we conclude?
Nothing on my side. Just to thank the attendees for attending this webinar, and we are happy also to answer to further questions offline through email. Feel free to reach us. This has been an overview, a high-level overview of 4 years of work, so it cannot be very much detail. We could not explain everything. So we will publish deliverables, we will publish papers are ongoing, and we are happy to answer to specific questions by email.
Indeed. So yes, if you're interested in further information, keep an eye on the website. There's also a newsletter that will be issued very shortly, including all the information from the evaluation results and also the deployment work that has been done through those 47 months of work. So yes, thank you all so much. Thank you for joining us, and wishing you all a great rest of your day.
Thank you, everyone. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.